All right, y'all, so let's go back now to the pad. All right, so 8.3, like I said, is over polynomial division, and we're going to focus on synthetic division. So we can use synthetic division for three things. First thing we'll use it for is finding function values. So if I'm using synthetic division to find function values, then the remainder is equal to the function value. All right, and you'll see problems doing that in a second. Second thing I can use it for is to determine if a number is a zero for a polynomial. So determine if a number is a zero of a polynomial. If a number is a zero of a polynomial, then the remainder will equal zero. And y'all, the third thing I'll use it for, and this will be in the support part of it, but I'll use it to find quotient and remainders. So find a quotient and remainder. Okay, so I'll do problems showing you all three of these, okay? So the easiest way to learn synthetic division is to sort of write the steps as we're working one of these. So we're going to work one while we do our steps, okay? So we're going to use synthetic division to find the function values. So we're given f of x equals x to the third minus 12x squared plus 41x minus 30. So they want us to find f of 1, f of -5, and finally f of 6. So before to do this, you just take the number like f of 1 and you'd put a 1 in for all the x's and see what you got. Same thing with f of -5 and f of 6. But y'all, we're going to use synthetic division to solve this. So over here, I'm going to write my steps as we go through this problem. So y'all, the first thing you want to do is write the coefficients of the polynomial. So my coefficients would be 1, -12, 41, and -30. So we don't write the variables, only the numbers. Also, here's another thing. If you have any missing terms, you must use a 0. So this one's not missing any because I got my x third term, my x squared term, my x term, and my constant term. So what you're going to do, you're going to see what your highest exponent is, and then everything else must be in descending order. So if I had an x3, an x2, but I was missing this 41x, I would put a 0 here for it, okay? So the last one I do that shows you the support type problem is going to have a missing term, and we will have to use a 0, okay? Now, under your coefficients, I draw a box. And on the right side, I make that a perfect little box there, okay? So, draw the box under the coefficients. So what's going to happen, this part right here will give me my quotient. The little box that we circled here, that will be our remainder. And remember, since I'm finding a function value on this, we set up here that the remainder is equal to the function value. So whatever I get in this box is what f of 1 will equal, and so on. So over here is where we put what we call our C. So put C into its position. So C will be the number we're evaluating. So since I'm finding f of 1, my first C will be 1. All right, so I'm going to pull this down a little bit. All right, so synthetic division is a repetitious type process. So the first thing we do, the first number of the coefficients, we always bring that first number straight down into the box. So bring the first coefficient down. Into the box. All right, so here's what a repetition becomes, okay? Any number that's down here, we multiply by C to get the number in the next column. So y'all watch this. I'm going to do 1 times 1 is 1. So I put that 1 under that negative 12. So multiply the number times C and place into the second column. All right, so I did 1 times 1, gave me 1. I put it in my second column here. Now, add the column. And put that answer in the box. So here we go. Negative 12 plus 1 gives us a negative 11. So we're going to bring negative 11 down into the box. Now we repeat. The negative 11 down in the box multiplies by the 1 and gives me my third column. So negative 11 times 1 is negative 11. So I place that number in the third column. So now all we're doing is repeat the process until done. All right, so we got a column here. We're going to add that together. 41 and negative 11 give me 30. 30 is in the box. So now I multiply by 1 and get my last column. So 30 times 1 is 30. Add that last column to get our remainder. So negative 30 and 30 will give us 0. So what that tells us is that f of 1 equals 0. Same answer I get if I put 1s in for all these x's. Y'all, we got 2 more on this problem to do, and hopefully y'all won't find this too bad. So let me flip this. So now we're going to find f of -5. So write your coefficients down. There were 1, -12, 41, and -30. I'm going to draw my little box. Since we're finding f of -5, C will be -5 this time. All right, y'all, so watch the process, same thing. Bring the first number down every time. Then multiply by -5 to get the next column. So 1 times -5 is -5. Add these together, -12 and -5, give me -17. Repeat the process. -17 times -5 is a positive 85. Add that column. That gives me what? 126. 126 times 5. What's that? Looks like 630, and it's going to be negative. So -630. So y'all, once we add that, we will have f of -5. So -630 plus a -30 gives me a -660. So f of -5 was equal to a -660. Now I sort of like doing this better than plugging those numbers in and playing with those exponents and all that fun stuff, okay? All right, y'all, the last one was what? F of 6. So our C is going to be 6 this time. We write our coefficients. And then underneath, I'll put my box. So y'all want to try that real quick and see what y'all get? And I'll look at y'all's chat to see what y'all get. So that way we'll know if y'all are getting this or not. Because it's not too bad once you get it. Oh, so I got a 0 on the board. So let's see if that's right. So I'll bring that 1 down. 1 times 6 is 6. -12 and 6 gave us what? A -6. -6 times 6 was -36. 41 minus 36 gave me 5. And y'all look at that. 5 times 6 is 30. Add those together and we get a 0. So f of 6 is definitely equal to 0. So good job. All right, y'all. So that was finding function values. So let's look at our next example here. This next example says using synthetic division, determine whether the numbers are zeros. All right, so they're wanting to know if -5 and 2 are zeros of f of x equals 3x to the third plus 10x squared minus 19x plus 30. So if these numbers are zeros, when I check them, I have to get a remainder of 0 for that to be a yes. Anything else is a no. So we're going to write our coefficients, and I have no missing terms because I got my x3 term, x squared term, x, and my constant term. So I got 3, 10, -19, positive 30. So I'm going to draw my box. So my first C will be the -5 they want me to check. All righty, so if I get a 0, it's yes. Anything else is no. So here we go. We bring our 3 down. 3 times -5 is -15. Goes in the second column. Add that column together. 10 and -15 give you -5. -5 times -5 is 25. Goes in the next column. Oh, so I think y'all are getting sorry. Okay, so you're getting zeros on that. So I think you're going to be right. So that gives me 6, and then 6 times -5 is -30. So I got a 0 remainder. Good job. That is definitely a 0. So what was my other number? That was a 2. So let's check 2 now. So 3, 10, -19, and 30. All right, y'all, so here we go. Bring that 3 down. 3 times 2 is 6. 10 and 6 give you 16. All right, let's see. 16 times 2 is 32. 32 minus that 19 gives us 13. And so it looks like y'all are saying remainder 80. So let's see. 13 times 2 is what, 26. So there you go. And that gives me what, 56. So as long as you're not getting a 0 there, that is definitely a no, okay? We are getting right ones on these. So let's see what this one says. So I'm going to turn it up on this one. So y'all check this out. Is 1/2 a 0 of f of x equals x to the third plus 1/2 x squared plus 5/2 x minus 3/2. So your last one in the college algebra part of this class will hit you with some fractions in 8-3, okay? But y'all, this one's not that bad because they all got the same denominator. So watch this. Our C is going to be the 1/2, so that's the 0 we're checking. My coefficients are 1, 1/2, 5/2, and then a -3/2. Draw my little box. All right, so y'all watch this. It's not bad. You bring the 1 down. And look at this. 1 times 1/2 is 1/2. And remember, adding fractions, add the top, put that over the bottom. So 1 and 1 give me 2, divided by 2. So 2/2 is a 1 again. All right, here we go. 1 times 1/2 is 1/2. All right, let's see what that gives us. Add the top. 5 and 1 give me 6 over 2. 6 divided by 2 gives me 3. 3 times 1/2. So remember, when you multiply 3 times 1/2, treat the 3 like it's got a 1 on it and multiply straight across. So 3 times 1/2 gives me a positive 3/2. And y'all look at that. Negative 3/2, positive 3/2 gives us a 0 remainder. So yes, 1/2 would be a 0 of that polynomial. So y'all, this ain't bad. You just got to get used to the pattern. Bring them down, multiply, get the next column. Add them together, bring that answer down, multiply, next column. Okay? All right, so this next problem will show you what your support wants you to do. So this one is for support. So they'll either say divide, or they might say find the quotient and remainder. So I'm going to say find the quotient and remainder. So some of these will just say divide. Okay. So they're giving these in parentheses. They're giving me a to the third minus 9a squared plus 9 divided by parentheses a minus 4. So y'all check this out. I got my a third term, my a squared term. I'm missing the a term, so I will use a 0 for that. And then I got my constant number at the end. So I'm going to write out my coefficients first. 1, negative 9, 0, and 9. So we always need placeholders for any missing terms. So since missing the a term, we use a 0 in its place. Okay, so a3, a squared, a number. Now, here is where the support is different from the college algebra. When they give you a factor like this, a minus 4, your c is always opposite in sign. So since that's a negative 4, my c would be a positive 4. Okay. So remember, the factors always have opposite signs than the actual zeros. So if I said find f of 2, we use the 2. If I said find out if 3 was a 0, we use 3. But when you got factors given instead of numbers, you change the sign. Okay. Now, draw your box. Now, here's the thing. When we're done, this part will be my quotient. In the box will be my remainder. Now, right here, these numbers will be in order. But the quotient, it's going to start 1 degree less than the polynomial. So what I mean by that, we started with an a to the third. This quotient will start with an a squared, then have the a, then my constant number, then my remainder. It always starts 1 degree less than your highest exponent. So let's get our numbers, y'all. So first, bring down that 1. Now, 1 times 4 is 4. So I'll put my 4 in the second column. I'm now going to add that column. -9 plus 4 gives me a -5. So now I'm going to repeat my process. -5 times 4 is -20. Add that column, 0 and -20, give you a -20. And then finally, -20 times 4 is a -80. And y'all, let's see, -80 plus a 9 would give me a -71. So remember, this quotient I said starts 1 degree less. So this means I have 1a squared minus 5a minus 20. That would be my quotient, and my remainder would be -71. Now, another way that they might write this, depending on how they want the answers, they could make this a squared minus 5a minus 20, and then they sort of write the remainder as a fraction. So -71. On the bottom of the fraction, they always put what you were dividing by, the a minus 4. Sort of like when y'all did long division with numbers and you had a remainder of 3, you would say that was a remainder of 3, but since you divided by 5, you could put that as a 3/5. So most of them want this way, but there is some where they give you A, B, C, D, where they want the remainder written as a fraction. All righty, y'all, that's 8-3. So we're going to get started in 8-4. So that synthetic division, y'all like that?
I love it.
It's not too bad if you get the hang of it. Now, I will say this. In the start of 8.4, I won't be using synthetic division. But when we come back Thursday for the last part of 8.4, we're going to do a lot of synthetic division, okay? So let's get started in 8.4. 8.4 deals with what we call theorems about zeros. All right, so watch this first example. The first example wants me to find a polynomial, degree 3, with zeros of -2, 3, and -6. So we're going to take the zeros, which are the solutions, work backwards and come up with a polynomial. Now it says my polynomial has to be degree 3, so that means the highest exponent when I'm done has to be a 3, okay? So that's what they mean by that, degree 3. So we're going to work totally reverse of what y'all did when you found zeros a few sections ago. So since they're telling me these are zeros, I know that x equals -2, x can equal 3, and x equals -6. So remember, zeros and solutions are the same. So I write them as solutions first. So write as solutions. Now, y'all, the second thing I need zeros on the right side. So to get zeros on the right side, I'm either going to add or subtract numbers, okay? So since this is a -2, we're going to add 2 to both sides. So we get x plus 2 equals 0. This one has a positive 3, so we're going to subtract 3 from both sides. X minus 3 equals 0. And y'all, this goes back to what I was telling you. Since negative 2 was the 0, x plus 2 is the factor. If x equals 3, x minus 3 is the factor. And if x is negative 6, x plus 6 is a factor. So now, I'm going to place each of these factors in parentheses and set this whole thing equal to 0. So place each factor in parentheses. And guess what? We're about to FOIL until done. So I'm going to FOIL 2 of these at a time. I've got 3 sets. So I'm going to work on the side here. On the side, I'm going to FOIL this, and then I'll put it in place. So right now, I'm just going to bring down my x plus 2 and figure out what's going in here. So on the side, I'm going to figure out what x minus 3 times x plus 6 equals. Oh, she must have got knocked off. Okay. All righty. So FOILing this, x times x is x squared. X times 6 is 6x. Negative 3 times x is negative 3x. Negative 3 times 6 is negative 18. And y'all, I'm just want to combine these like terms in the middle so that I get an x squared. 6 minus 3 gives me 3x minus my 18. I'm going to put that now into my parentheses. So y'all, let me tell you this. You could have FOILed these first 2 first. Okay. The reason I do the last 2 is because I like having 2 things in front multiplied by 3. If you'd have done these first 2 first, you'd have had 3 things here and then your 2. So it's sort of easier to keep up with if you got 2 in front and 3 in the back. Because now I'm going to take this and FOIL it. So I had to FOIL right here, these 2. Now I'm going to FOIL this one times these. So the x, I'm going to start with x. I'm going to multiply that x times the x squared and get an x to the 3rd. X times 3x gives me a 3x squared. And then x times the negative 18 gives me a negative 18x. So you distribute the x through. Now we'll distribute the 2 through here. 2 times x squared is 2x squared. 2 times 3x is 6x. 2 times negative 18 is a negative 36. And technically all this is equal to 0 still. So let me separate this. Y'all, so at this point, all you can do is combine like terms. So there's only one x to the 3rd, so I'm bringing it down. The 3x squared will add to the 2x squared. That'll give us 5x squared. This negative 18x will add to the positive 6x and give me a negative 12x. Then bring down your negative 36 equal to 0. But y'all, all Math Lab wants is this polynomial. My exponent is a 3, so I got a degree 3 like they wanted. And we used the zeros of negative 2, 3, and negative 6 to get our polynomial. So a lot of fun there, right? It is definitely sort of backwards, ain't it? All right, so before I do the next one, I'm doing a little recall with this. I squared, because we're about to FOIL some imaginary numbers. So just remember this. Whenever we get an I squared really equals -1. So if I end up with an I squared in one of my problems, I'm going to replace it with a -1, okay? Also recall this. If you multiply a radical times itself, you get what was under that radical. So if I did a square root of 3 times the square root of 3, that would equal 3, okay? So these are just some things we need to know when we start venturing into the next problem or two, okay? All righty, so here we go. We want to write a polynomial with zeros of 3, 5i, and -5i. So that means x equals 3, x equals 5i, and x equals a -5i. So we got our solutions. So now we're going to get zeros on the right side by adding and subtracting. So the first one, I'm going to subtract 3 from both sides. Then I get x minus 3 equals 0. Then I'll subtract 5i from this one. X minus 5i equals 0. And then add 5i to the third one. All right, so now we have our 3 solutions. We're going to put these back into parentheses so that x minus 3 times x minus 5i times x plus 5i all are equal to 0. Now, the one I just did a while ago, I had 3 real numbers. So order didn't really matter to me. But y'all, when you got imaginary numbers, I would start fooling with those imaginary numbers first. Because here's the thing. These are conjugate pairs. And conjugate pairs means they look exactly the same other than one's being subtracted, one's being added. So watch what happens on the side when I FOIL this. So x minus 5i times x plus 5i. X times x is an x squared. X times 5i is a 5ix. Okay, so let me see. I got an x squared plus 25. Oh, look at y'all go. Good job. That's going to give me what? A -5ix. And then at the end is a -25i squared. So that was good because those cancel in the middle. One's positive, one's negative. So these cancel. And remember, I got an I squared. So I'm going to replace the I squared with a -1. So it brings down the x squared. All that -1 is doing, when you multiply by that -25 times that -1, it's going to make it a positive 25. So, hey, that was a good job because you got me a x squared plus 25. Good job. So bring down the x minus 3. that became an x squared plus 25, all equal to my 0. Now, y'all check this out. Anytime you FOIL conjugate pairs of imaginary numbers, I don't care what this number is, it's always going to be x squared plus whatever number you get at the end. It's always going to be positive, okay? All right, so we replace that. Now we got 2 things times 2 things. So we're going to FOIL again. Well, here we go. X times x squared is x to the 3rd. X times 25 is a 25x. Negative 3 times x squared is a negative 3x squared. Negative 3 times 25 is a negative 75, all equal to 0. So y'all think the only thing I would do to that would be what? Rearrange that so that I get an x third minus 3x squared plus my 25x minus my 75 equal to 0. Okay, so they gave me 3 numbers up here. So that means my exponent has to be a 3 when I'm done, okay? All right, questions on that? All right, so we'll move this down and get this next one. So the next one, we're going to hit radicals. So write a polynomial with zeros of square root of 2, negative square root of 2, and 3. So I'm sort of picky with the radicals too. So since I see the radicals, I'm going to put my 3 first. I'm going to put x equals 3. Then I'll put my x equals square root of 2, x equals negative square root of 2. So I'll have to keep the radicals at the end like I did these imaginary numbers a while ago, okay? All right, let's get to zeros by subtracting, and adding. So subtract 3. X minus 3 is 0. Subtract the square root of 2. X minus square root of 2 equals 0. And then add a square root of 2. So x plus square root of 2 equals 0. All right, we got the factors. Now we're going to set them in parentheses. So here's what I'm going to do. I'm going to start with these radicals on my side work. So notice up here, when we FOIL those conjugate pairs of imaginary, it gets rid of the imaginary. When you FOIL conjugate pairs of radicals, it gets rid of the radicals. Whoop, one's minus and one's plus. So yeah, this is about to get rid of these radicals since these are conjugate pairs. So y'all, here we go. X times x is an x squared. X times square root of 2 is a positive square root of 2 times x. Negative square root of 2 times x is a negative square root of 2 times x. And then the negative times a positive will make this a negative square root of 4. So 2 times 2 under the radical is a 4. But y'all remember, square root of 2 times square root of 2, basically when I'm done will give me a 2 here, okay? Because we said a radical times itself ends up giving us what was in the radical. Well, square root of 4 is 2, so that's going to be true, okay? The 2 middle terms cancel again. So this will give me an x squared minus the square root of 4, which is 2. So bring down your x minus 3. Replace this with x squared minus 2. And that's technically all equal to 0. So check this out. When you foil imaginary, it always ended up positive on those conjugate pairs. When you do conjugate pairs of any other type number, whether it's in radicals or whether it's whole numbers, it's always going to be x squared minus your number, okay? All righty, so we got one more part to foil and we can be done with this. So here we go. X times x squared is an x to the third. X times negative 2 is a negative 2x. Negative 3 times x squared is a negative 3x squared. And then y'all, negative 3 times negative 2 is a positive 6. So I'll probably put this in order. X to the third minus my 3x squared minus my 2x plus my 6, all equal to 0. But y'all, all Master Lab wants is the polynomial. I had 3 zeros right here. So remember, my exponent I ended up with was a 3, okay? All right, so I'm not going to lie, y'all going to be foiling a lot in this section 8.4. Especially on the first half of it, okay? All righty, so moving on. Let me flip my paper over. All right, y'all, check this one out. It says, where am I at? Find the polynomial degree 3 with zeros of negative 1/5, 0, and 4. All right, so I know x equals a negative 1/5. X equals 0. And x equals 4. So check this one out. I've already got a 0 on this one. So all I got to work on is the negative 1/5 and the 4. So here, 2 ways you can do this. So I'm going to show you what I do to this. So the first thing I do to get the 5 off the bottom of that fraction, I'm going to multiply both sides of this by 5. That'll give me a 5x over here. Over here, the 5's cancel, and I get a negative 1. Now, I need a 0 over here, so I'm going to add 1 to both sides. So I end up with a 5x plus 1 equal to 0. So anytime you had fractional answers, you always had numbers in front of that x. All right, x equals 0 is done. So the last one, we'll subtract 4 from both sides. So I get x minus 4 equals 0. So I'm sort of picky on these ones. Anytime I have a single x, I put that in the front. And then I put in my 5x plus 1. And then my x minus 4. Always put the single x's up front because it's easier to do them on the last step, okay? So notice a degree 3, I got 3 factors. So I'm going to start out multiplying these two together by FOIL. So on the side, we're going to FOIL 5x plus 1 times x minus 4. All right, y'all, so here we go. 5x times x is a 5x squared. 5x times negative 4 is a negative 20x. 1 times x is a positive x. And then 1 times negative 4 is negative 4. Combining like terms in the middle, I get a 5x squared minus 19x minus 4. So I bring down that x, and in my parentheses, I'm putting my 5x squared minus 19x minus 4. All right, now the reason I put this x out front, now to multiply that x, all I got to do is distribute that x through these parentheses. So x times the 5x squared is the 5x to the third. X times negative 19x is a negative 19x squared. And then x times negative 4 is a negative 4x. All equal to 0. So y'all, here's the thing. On this problem, we need the x3 term to have a 1 in front. So they don't want a 5 in front of the x third. They want that to be a 1. So to make that a 1, you're going to take everybody and divide by that 5. So watch this. The 5's cancel, you get an x to the third. Can't do nothing with that, so that's going to stay a negative 19/5 x squared. Can't do nothing with the 4 divided by 5, so that's going to be minus 4/5 x, and all this technically equal to 0. So your final answer would be this. So y'all, here's the thing. I think it's easier to do it this way. The other way you could have done it, when you was up here and you had x equals negative 1/5, you could have added 1/5 to both sides. And you would have had x plus 1/5 equals 0. But then you would have been foiling that instead of these nice little straight answer here, okay? You'd have been doing x plus 1/5 times x minus 4. So you'd have been multiplying and adding fractions. So that's why I like to do it like this. So you don't have fractions when you're foiling. And then take care of that on the last step by dividing by the 5, okay? So this way, if you put that as one of the factors, is a little bit tougher, okay? All righty, so you're going to love it when you have zeros here, because all that is distributing them x's at the end, okay? All righty, y'all, moving on. I'm probably only going to do about 1 or 2 more of these, okay? Find a polynomial degree 6 with -2, a 0 of multiplicity 3, zero, a 0 of multiplicity 2, and 2 as a 0 of multiplicity 1. So the fun part, this is now going to be a degree 6, which means when I'm done, my highest exponent will be a 6. So what we need to figure out is, What do they mean by -2 is 0, multiplicity 3? So what do y'all think that means? Oh, so I got you on that. So remember, multiplicity is how many times a factor happens. So if they're telling me -2 is a 0, multiplicity 3, that means x equals -2 happens 3 times. Okay. Then they're saying, hey, 0 is a 0, multiplicity 2 times. That means you have x equals 0 twice. And then 2 is a 0, multiplicity 1. That means we have x equals 2. So remember this, since that's a degree 6, y'all better have 6 factors sitting here, okay? So now, these two already have zeros, so I don't have to mess with them. I just got to mess with the other 4 factors. So for the first 3, we're going to add 2 to both sides, and we'll get x plus 2 equals 0. All right, them 2 are good. So the last one has a 2. We're going to subtract 2 from both sides and get x minus 2 equals 0. So these single x's I'm going to put in the front again. So I'm going to do a x times the x, and then everything else is going in parentheses. X plus 2, x plus 2, x plus 2, and then x minus 2. And technically all that would be set equal to 0. All righty, so I'm going to FOIL the first 2 together. I'm going to FOIL the last 2 together on the side here. So I'll have 2 that I'm going to do on the side, okay? Now, x times x, I can fix that real quick. So this x times x in the front would give me an x squared. So now I got to see what's going to happen to both of these. So I'll put 1 in one parenthesis, the other one. Okay. So let's start with the x plus 2 times x plus 2. See what that gives us for our first parentheses, and then over here we'll figure out x plus 2 and x minus 2. So x times x is the x squared. X times 2 is 2x. 2 times x is 2x. And then 2 times 2 is 4. Adding those like terms, because they're both positive, gives you an x squared plus 4x plus 4. So I'm going to put that right here. X squared plus 4x plus 4. Now over here, I'm going to figure out what is x plus 2 times x minus 2. And y'all check this out. These are conjugate pairs, so a lot of stuff is about to cancel. So x times x is x squared. X times -2 is -2x. 2 times x is a positive 2x. And then 2 times -2 is a -4. So these like terms in the middle cancel. So this ends up as an x squared minus 4. So remember, we said anytime you FOIL conjugate pairs of real numbers, it's going to be x squared minus some number, okay? So I'm going to put that right here, x squared minus 4. All righty, so now we got an x squared times this parentheses times this parentheses. I'm going to FOIL this part first. on the side. So y'all watch this. I'm going to put the two parts up front, the x squared minus 4, and multiply that by the x squared plus 4x plus 4. I'd rather have the smaller ones up front, so then you're just distributing two things. If you had the 3 up front, then you'd have to distribute 3 things, okay? All right, here we go. X squared times x squared is x to the 4th. So remember, when I'm multiplying these variables, I'm just adding those exponents, okay? X squared times 4x is a 4x to the 3rd. And then x squared times 4 is a 4x squared. So basically, since you multiplied by x squared, all these exponents went up by 2. That went from 2 to 4, 1 to 3, 0 to 2. Now distribute that negative 4. Negative 4 times x squared is a negative 4x squared. Negative 4 times 4x is a negative 16x. And then that negative 4 times 4 is a negative 16. So I'm going to add like terms and put that answer over here. So I'll have my x squared out front by whatever I get in these parentheses. So let's see, adding like terms, I got an x to the 4. I got what, 4x to the 3rd. Oh, y'all, look at this. Positive 4x squared and a negative 4x squared, those cancel. So they cancel out. So then I have my negative 16x and then my negative 16. That's going in this parentheses. All righty, so now the fun part. Since I got an x squared up front, I'm going to distribute it through these parentheses. So I'm going to multiply it by all 4 parts in there, okay? So the x squared times the x4 gives me an x to the 6. X squared times 4x third gives me a 4x to the 5th. So notice I'm just adding 2 to all these exponents. X squared times negative 16x is a negative 16 x to the 3rd. And then finally, the x squared times negative 16 is a negative 16 x squared. Remember, all equal to 0, but all MathLab wants is our polynomial. They wanted this to be a degree 6, and guess what? We ended up with a degree 6. All right, y'all. So the last little thing I'm going to show you in this section. And it talks about the zeros. So these are rules about zeros. So the first rule, imaginary zeros always come in conjugate pairs. So if AI is a 0, then negative AI is also a 0. So replace the A with any number. So if this was 3i, then negative 3i is a 0. If negative 4i is a 0, then positive 4i is a 0. So they're always in conjugate pairs. The second one is radical zeros always come in conjugate pairs. So radical zeros always come in conjugate pairs. So that means if square root of A is a 0, then a negative square root of A is also a 0. Okay, and that's because both of these are really radicals. And radicals, when you took square roots, had that plus or minus in front of them. So that's how come they're always in these conjugate pairs. So let me do a few of these and then y'all ready to go. So y'all, and I'm gonna let y'all try to answer this. So say a polynomial degree 4 has zeros of -2, square root of 5, and 11 halves. What is the other 0? So y'all, if I give you a polynomial degree 4 and I said it had 4 zeros, and I give you a -2, a square root of 5, and 11 halves, what is my 4th 0? Well, let me see what I'm seeing there. I'm seeing let me read that, negative square root of 5, perfect. Negative square root of 5. And that's because these radicals always come in conjugate pairs. All right, same thing. Polynomial degree 4 has zeros of I and 8 minus square root of 11. What are the other zeros? Well, this is a little trickier, so let's see what y'all say. I got an I and then an 8 minus square root of 11. So I got a, oh man, that's perfect, a negative I, because remember the I's are in conjugate pairs. And then this would be an 8 plus square root of 11. So good job. You only changed the sign on the radical part, not the number in front. Okay. So good job on that one. All right. So the last one, polynomial degree 4 has zeros of 4 plus 2i. So let me move this camera down a little. 4 plus 2i and 4 plus square root of 3. What are other zeros? So y'all get me these two and we'll be done. So let's see. I see one of them is a 4 minus 2i. Right, so 4 minus 2i was the conjugate of a 4 plus 2i. And then I'm getting 4 minus square root of 3. Good job. 4 minus square root of 3. So y'all, when you got two terms like that, you only change the signs in the middle, okay? All right, so in 8.4, you can work up to number 10. So we'll pick up from number 10 the rest of this work. So you should be able to knock out 8.3, which was doing your synthetic division, and then work 8.4 up to number 10, okay? Number 10 we'll pick up on when we get back, and it's going to start hitting us with a little bit of synthetic division and that fun stuff. So let me see, do I have any questions, y'all? All right, so no questions. So let me stop my share and my record.